Kiyotaba mfana boss. So, organic chemists. Let's continue with organic chemistry. Today's session is going to focus now on what we call physical properties of organic compounds. But before we can even talk about those physical properties that we are going to talk often about, let us try to see, have a glimpse, just to have a look at what type of questions will definitely come out under classification. This, of course, is under classification of or rather classification of these organic compounds. So we definitely must be able to classify these organic compounds. Now, the first question perhaps they ask here, they were being fair and lenient. They said define an organic compound, which we know that by now we understand that when we talk about organic compounds, we are talking about the study of carbon-containing compounds. You can agree with me that all these compounds that are here, they have carbon somehow. So that's why we study them. We want to classify them. And I mentioned in the previous session that, well, these compounds, honestly, you just have to be able to classify them. And in actual fact, this part of the examination will be very easy. Look at free 16 marks. Very easy. All you have to do is to classify those organic compounds that you are given. So some of the things then that you must know in order to be able to classify organic compounds may include the following things. We are going to talk about what we call saturated versus unsaturated. So as organic compounds, perhaps for us to understand organic compounds, we must know the difference between the saturated versus the unsaturated compounds. So we definitely must know the difference between those. The saturated, of course, being those that only have single bonds, and then the unsaturated being those that have double bonds somewhere. For instance, look at E. E will be regarded as an unsaturated compound because it has double bonds between the carbon compounds. Do not confuse that with F. For instance, F, there is a double bond between carbon, but it is between carbon and oxygen. So we may not consider it as being unsaturated. So the multiple or triple bonds must be between carbon-carbon, or must be between carbons. So let us know how to classify saturated compounds versus unsaturated compounds. Another thing then that we must know is the language that is used in organic chemistry. For example, what are we talking about when we talk about the general formula, the molecular formula, the structural formula, things like that. We must also know as to what exactly are we talking about when we talk about a homologous series. So those things are very necessary. The language that we use in organic chemistry for us to be able to classify these organic compounds. So halala right now. So you can see then question 2.3 here wants us to give the structural formula as well as the general formula. So that is why I say make sure that we are able to understand the language used in organic chemistry. 2.3.4 wanting structural formula as well. And then they talk about the functional group. You must know what is a functional group under the classification of organic compounds. Now, another language that we'll be interested in, remember, isomerism. And I did have mentioned to say, well, when we talk about isomerism, we must understand that there are quite different isomers that we can think of and about. You must not be scared when you hear of the word functional isomer. You must not be scared when you hear the word chain isomer, positional isomer. So you definitely must know all those different types of isomers that we can have, because you will be traumatized when you are in the exam doing question 2.4.1 looking for the functional isomer, but we're now we keep blind with fun boss. So definitely the functional isomer, chain isomer, positional isomer, all those types of isomers, you must know them and know them thoroughly. So why bonatab and fun boss. So I hope you'll be able to attempt these questions. Now for us to look at the physical properties of these organic compounds, of course we must start perhaps by understanding the structure. So that is what we will perhaps be interested in, the structure of these organic compounds. Why? Because the structure so it influences what? It influences the physical properties. Propane, butane, pentane, they may be different somehow, similar somehow. Methylbutane, ethanol, and all those, they have different structures. Thus, they will have different physical properties. They will have different behavior. So now, it means we have to understand the structure, of course, by being able to classify the organic compound. After we've classified the organic compound, therefore, perhaps we will know that, okay, this belongs to this functional group. Since it belongs to this functional group, therefore, it is this particular organic compound. Therefore, we can be able then to talk about what? To talk about its physical properties. So some of these physical properties to think of and about so they include the boiling point. So we have to know the boiling point, the melting point, the vapor pressure, and things such as density. So those are things we have to talk of and about when we think of the physical properties of organic compounds. So right now, so we are given A to F there. We have to try to interpret as to what they want here. They say, let us investigate factors that influence the boiling points of organic compounds. And we know that, well, when we talk about the boiling point, we are talking about the physical properties. So remember, question 2 will usually be about classification of these organic compounds. Then question 3 will likely be about the physical properties of these organic compounds. So the boiling points of some organic compounds obtained are shown in the table below. We are given A to F, as I said. 3.1 says, define the term boiling point. So right now. And I don't think I've ever seen a question paper without having defined the term boiling point. Even the time I was writing my metric, there was a question saying define the term boiling point. So make sure you understand what is a boiling point, which is, of course, the temperature at which the vapor pressure of a substance equals the atmospheric pressure. It sounds scary, but just cramming is part of learning Mfanabo. So it's a definition. It will always be asked, and it will always be that definition. It won't change. The temperature at which the vapor pressure of a substance equals atmospheric pressure. That is what we say. Now they say the boiling points of compounds A, B, and C. So we are, of course, comparing few compounds here, A, B, and C. So here we are. Propane, so butane, pentane. You can see that in actual fact there is an increase in the chain length. There is an increase in the number of carbons. Remember, propane only has 3 carbons. Butane has 4 carbons. And then pentane has 5 carbons. So there is an increase in the number of carbons. So as there is an increase in the number of carbons, the question is, what is happening to the molecular mass? Well, we can see that there is also an increase in the molecular mass. 44, 58, 72, which implies an increase in the molecular mass. Now, as we increase the chain length, then remember we said as we go down, we are increasing the chain length from propane to butane to pentane. We are increasing the chain length. We see that we are also increasing the molecular mass, but we are also increasing what? We are increasing the boiling point. So we can see an increase also in the boiling point. So the boiling points of compounds A, B, and C are compared. How do the boiling points vary from A to C? Well, we just said as to what happens there. They say choose from increase, decrease, or remains the same. We saw that, well, the boiling points were increasing as we move from A to C. So increase will be the correct solution in this regard. Now they say explain your answer. Well, this is a very, very interesting question then, and you can see that it goes for up to 3 marks. Now what you are going to realize there is that, well, there is an increase in the molecular mass, right? So since we are increasing the molecular mass, we are increasing the chain length, we are increasing the surface, we are increasing the surface area, we are increasing the number of carbons. That's just what we are doing here, Mfanabo. So, and as we do that, it means we are strengthening the intermolecular forces. So the increase in molecular mass or the increase in number of carbons results to an increase in the strength of the intermolecular forces. So it means pentane has greater intermolecular forces than butane, and butane has greater intermolecular forces than propane. So, halala right now. So as we strengthen the intermolecular forces, that means what? That means there is now more energy. So more energy is needed then to overcome these strong intermolecular forces that we've spoken of and about. That's just how we explain this. If we increase the chain length, we increase the intermolecular forces. That means there is more energy that is needed in this regard. Now 3.3, the boiling points of compounds B, C, and D. So here we are, perhaps let me use this color here, black. B, C, and D is what we are comparing: butane, pentane, and methyl butane. So let's see the difference here. They say the boiling points, I'm lost now as to where I am. Okay, the boiling points of compounds B, C, and D are compared. Is this a fair comparison? Choose from yes or no, and give a reason for your answer. Now, can you see that B, C, and D, we are having pentane, or rather we are having butane, pentane, methyl butane, and we can see something is happening there in terms of what? Something is happening there in terms of the molar mass. So we can say, therefore, the result here will be to say, no, this is not a fair comparison. Why? When we compare things, there must be one independent variable. But in this regard, the molar mass is changing and the length, or rather the chain length, is also changing. So since there is a change in the chain length and the change in the molar mass, it means we're having more or two independent variables, which makes this not to become a fair comparison at all. We can see there is a change in what? We can see there is a change in number of what? There is a change in the molar mass, of course, and there is also a change. The reason we say there is a change in molar mass is because if you check, here we are having 72 and 72, that's fine, but we are having 58, therefore, which is different. And then we can see that, okay, also here, in terms of the number of carbons that are present here from butane, pentane, and methyl butane, there is also a change in that aspect. So we are having two independent variables, and that makes science not to be fun if we will have that. Let us have only one independent variable. If it is temperature, let it be only temperature. If it is molecular mass, let it be molecular mass. So, halala right now. They say the boiling points of compounds E and F are compared. Now let's see E and F and see, okay, what is the comparison there? They say, state the independent variable for this comparison. Well, we'll recognize and realize that, okay, the independent variable, of course, will be the functional group or the homologous series, or of course the type of intermolecular forces. If we compare the two, that would be the independent variable. Remember that there are different types of independent variables, such as what? Such as the functional group. Because if you compare E and F, they have different what? They have different functional group. They are in different homologous series. Thus, they will have different types of intermolecular forces. That will be the independent variable that we can think of and about. Write down the name of the strongest Van der Waals forces present in compound F. Well, compound F is just ethanol. What we know about an ethanol, of course, is the presence of a carbonyl, the C double bond O, the presence of the carbonyl there. So we know that, well, in terms of intermolecular forces, when we talk about the carbonyl, or rather when we talk about ethanol, we will know for sure there is a presence of carbonyl, which means that the forces that will be present therefore will be dipole forces. So that's what we can write here, dipole forces. It sounds nice. dipole forces. So that will be the solution. Therefore, I hope you know what are the different types of forces: the van der Waals forces, hydrogen forces, hydrogen bonds, dipole forces, induced dipole forces. You have to know those different types of forces. It's a must, it's a necessity. Now they say 3.5. Which compound, D or E? So we are comparing D and E. Has a higher vapor pressure, and give a reason for your answer. Well, what you'll recognize here is that D has a lower boiling point. So since it has a lower boiling point, we know that in the definition of boiling point, there is something called vapor pressure. So the higher the vapor pressure, the higher the boiling point. So D in this regard will be the solution. Why? Because if you check, D has a lower boiling point. It has 28 degrees Celsius as its boiling point. That is methyl butane. Whereas E, of course, ethanol, has 78 degrees Celsius as its boiling point. So we know that D will be the solution then in this regard. And the reason will be that there is a lower boiling point, which implies that there are weaker intermolecular forces. So welcome to Science Intellect Hub. So in the next session, of course, when we meet, we will try to talk about another activity, of course, here on these types of intermolecular forces, or rather on physical properties, and then we'll advance our knowledge then and talk about reactions. Can't wait to So reactions and reaction mechanisms.